Hello everyone. So let's try to revise Node.js today. Okay, this will be a, series of parts. Like this could be one, two, three. I don't know how many parts there will be. I think three. I'm aiming three parts. In three parts, I will provide all the material so that it covers entire Node.js. So let's start without wasting any time. Let's start the what is Node.js with a very fundamental question. Like the interviewer might ask you, explain what is Node.js, and your response could be something like, okay, Node.js is a runtime environment, which is good, but do you understand what it means when you say some things like that? A runtime environment, why not it's a language, why not it's a like a framework, right? So let's try to understand that point of view so that you can understand deeper what Node.js actually is. So by the definition, runtime environment, we means that runtime means a space with the tools like HTTP modules, functions like or file systems and OS level modules, such that our JavaScript code could run on the server. That's the runtime means. So Node.js provides that for JavaScript. If you remember, JavaScript was not supported on the server. Like it was not meant to be run on the server, right? It was just on a browser. It used to run on browser, right? But because of this Node.js, it provides essential things that we do on server. Like what do we do on server? Well, we access the file system, we make API call requests, we connect to databases, and all of these things, right? So this is what Node.js provide to the JavaScript. And environment means a space where it can run the code. So every other programming language also need the runtime to run their code, but JavaScript, sorry, Node.js, uh, it's just literally that it's just nothing extraordinary. It's just that it leverages that functionality like a file system, HTTP modules, and all of this thing. Behind the scene, it's built on C++ library, but it just connect to the uh, our server in the Node.js. When we run the code, like for example node app.js, and if we using this, we have these modules, HTTP file system, and all of these things, we have access to those. So when we are using them behind the scene, they are written into the C++, but we can kind of use that in plain JavaScript, so that it just gives the power to the JavaScript so that it can run on browser, sorry, on the server. And you can say something like, outside the browser, this is what it means when we say outside the browser. All right. But why not language? Why not framework? Well, in order to be the language, a language defines how we write our codes using variables, loops, functions, and classes, and all of these different syntax, right? But Node.js itself doesn't have any syntax, right? So that's why it's not a language. And framework, well, if you remember, framework help us to structure our code by providing some abstraction. Like we have some rules to follow. So for example, if you are familiar with express.js, it provides routing, and how should we define the routes so that different routes can handle differently. You know what I mean? But in Node.js, there's nothing like that. We are free to do whatever we want to do. It just creates server, it takes a callback function, request response, and then we have to like code our own way. There's no structure, so it's not a framework either. So that is why we say that Node.js is a runtime environment which provides some tools, additional tools that we need on server, like for example file system, HTTP, and all the OS level modules that we require uh, to perform like any backend language that works, like for example Python, Java, any of these things works the same way. We get into this JavaScript because of Node.js. And all the other languages are not just a runtime environment, because like for example, if you take an example of Python, Java, they have literally everything. They were created for the backend, so they have built-in modules for these HTTP file system and all of these things. But in JavaScript, it's nothing like that. So we kind of get this from Node.js. It creates this space where these tools are available for us so that we can use them, and that's what Node.js is. So I hope this is clear to you, and now you know better understanding of like Node.js overall. Okay. Now we will get into the second question, which is And this idea that why people are going crazy about Node.js. I mean, there are so many languages, but why Node.js is so much like this stack is getting so much popularity these days, man stack, because of this Node.js. Well, the first reason is you don't have to learn any specific language for backend. Like if you know JavaScript, you can literally work on backend. So that's the plus one. That is why people are switching to the companies, or people are preferring this Node.js. Sorry, the entire mind stack, because they know that if they learned JavaScript good, then they know they can work on Node.js also, and all of the different things. They don't have to learn new syntax. Also, there is a reason, which is the way Node.js handles this asynchronous tasks. What do I mean by that? So, for example, Node.js is single-threaded, meaning one task at a time. All right, but still, the way it handles these heavy tasks, using asynchronous way, using event loop and all these things, we will talk about it into the video moving forward. But this asynchronous way of handling these tasks, it makes Node.js faster. You see what happens whenever like for example, what are the tasks that takes so much time? Reading file from somewhere, making database connections, or putting code to the like our data to database, and making a networking request, things like that takes time. So instead of just waiting for them, what Node.js does smartly is that it puts these tasks to the libu library, or libu, that handles these tasks behind the scene. And while the libu library or enter or like interly or internally, any of us asynchronous task or management is handling these tasks, our main thread is free, meaning it can take new requests, although those tasks were not done yet. They are happening behind the scene, but it's not waiting for them to happen, so that it can send the request to the client and then take the next request. Instead, as soon as it gives this task to the internal mechanism, to the libview or any other responsible uh, task management, what it does, it frees the call stack, which is responsible of running the code, right? So it frees that, and as soon as it frees, it can take the next request. So that is why it we call it non IO block, meaning any task that depends on input output, like CPU, like synchronous task, like for example any file reading, HTTP request that we are making to the another API or microservices or database connection. These tasks take time, so we are not waiting for them, so we are not like blocking. That is what the word non IO blocking, just taking new requests. And once those tasks are done, like for example the tasks that were file reading or any database connections, whatever the task was, they were done, the review library or the uh, respective task management sends those tasks to the event loop, and event loop manage them uh, appropriately. And we will get into that how this works and all of this. But because of this asynchronous behavior, asynchronous way of handling, and non-blocking the thread, because of these things, Node.js is crazy fast. Now, obviously, it has its all drawback also, like into this any synchronous task that takes time. We shouldn't be doing that. For example, CPU intensive task basically, like for example, video processing, image processing, or any AI related thing. We should not be using Node.js because it will block, and that is not good, right? So that is entire overview of what is Node.js environment, what it does, why people like it, and all of these things, different things. So I hope you get the idea. So let's move to the next question. Okay, so the next question is, what are events in Node.js? Well, remember how we had this document object model in browser, where uh, we can attach the event listeners to the, like on click, on button, form submission, on press, on key up, or inputs. We could just attach like something is happening. Like for example, if I click the button, it's an event, right? Like on click event. on submission event, something like that, right? So we had this thing in the browser, but on the server we don't have something like that. We don't have the DOM on server. So this is what events is equivalent to DOM in the server. Basically what it does is it's a mechanism, or we can say a language of Node.js, to let the system know that okay, something happened, something is done. So what do you want to do with that? So for example, it could be like okay, the remember the file we are reading, so it's done, like reading part is complete, or the file we are reading, some error occurred. So on error event, on data event, or a new request has come on server, so this is also an event. So these are events. Basically something is happening, something happened, or something, whatever, it could be error, it could be success, whatever. We want to do certain things on when that. And this is very powerful because remember I was talking about how Node.js is crazy fast. Well, the reason it is fast is because it utilizes the events behind the scenes. Although we don't use it on day to day, like on the very core level, but behind the scene that we use Express and all of these things, they all utilize the events behind the scene. So it would be a great way to learn is how Express works and to build your understanding of it. So what are they and why do we care? Let's get into this thing. So I think it would be better if I showed you with an example of how to create event so that we can get understanding of it. Okay, so let's go to here. So I built this Node.js learning folder and there's an app.js. So there's a module called events in Node.js. Remember, Node.js is a runtime environment, so it provides this module to us. It's a tool so that we can use it. Okay, so let's require it, meaning the way we use it. First we require const event emitter. You can name it anything you want, but this is a very classic and people use it all the time. Require the events. This is what. So let me make it my own event. Okay, so how can I make it? Const, sorry, not const, class. I am making new class which is I want to say chat, um, just a random chat, chat event, uh, and it will extend this event emitter. That's it. Oh, I don't have to do this, I can just do this. And here const, I will make a new object called chat emitter, new chat event, something like that. Now we need to understand two things about events. We can register them and we can use them. So registering meaning we want to register, we want to write. So for example, we can write our custom event like, okay, if my custom event, we can name it anything. So for example, we can login. So we want to do certain thing when user logged in. This is, and we want to register as an event also. Like okay, if the user is logged in, we want to do this thing. So this registration process is done by own method, that is this event providers. We can register that. And how do we use it? Meaning emit. This is what the term is, emit, meaning we want to use it. So for example, let me just code it so that you can get better understanding. Chat emit dot on, and this on method is coming from this event emitter, which in this module. We don't have to do it. And this is a function. This takes a callback function, which is a first name of the event. So as you can see, we can name anything whatever we want. So we can name it login. As I said, I want to make a login event, and then comma, and then it's a callback function. And we can currently we can just say ki I, or we can say user is logged in. We can say that, right? This is a, if I run right now, nothing will happen. But if I do this chat emitter dot emit, is also a method that is coming from this event module. Emit, and if I pass the login, so what will happen is that this is how we use it, this is how we register it. Simple. So basically, this is where we're registering it, that what we want. It's a custom event that we are registering it. That we want this event to happen whenever, and how do we want it to happen? Well, it's up to us. How do we want to call it? So, for example, there will be a login route where you wrote the logic of your login, and this is where you can use this, because you can define events in your separate class and then register it, and you can just use like this, like import this class and then use this object. Okay, so if I do this node app, and you can say user is logged in, nothing is surprising right now. So let me show you right now that if I log here, hi, so as you can expect, this will run first and then second. So user logged in and hi, it's synchronous. So if you have to remember this thing, the events are synchronous by default. Just because we are writing that way, it doesn't make them asynchronous. So currently you might say, okay, wait a minute, Ajay, that okay, it's a good thing, but I can do this thing, like events like this work. I can use the functions also. I can define functions, uh, event function, and I can just call this function like this. And what is so special about it? The problem that it is solving right now is that it listens. For example, remember I told you that event loop is listening behind the scene. Okay, the libview will do the work for us of file reading or asynchronous task. Well, when there is asynchronous tasks are done, how do you think that that system notifies that event loop? Well, that is done by these events. If event we didn't have events, we wouldn't be able to call them or do these things. Or if we were able to do that, they wouldn't be organized the way it is. So now you know how to create these events, right? First, you import or require them. You can name it anything you want, but it is classic way of doing it, so that's why I did. You register the event like this, you call it. You can later register so many events like this on the same name. Login, user is logged in, and something else. It will run both. User logged in, user this. This is the beauty of it, like so that you don't have to like rewrite that function. If you wrote the function, you are like binding to that function. Now you can define that, okay, login event happen, this is happen, but if you want something else also happen, you can do that also without rewriting the function. Okay, so that's the beauty of the event. You can register so many events with different functionality. Now this is just a basic way of showing you how does events are created, but let me show you the real power of events. Okay, so let me just erase this, and let me just write, and this is a file data, there is a basic text file, and let's go here. So let's try to see the use cases of it. So I want to read this file, and as I said, reading file is a not synchronous task. It will be done by libview library, so that main thread doesn't get blocked, and the reason I will show you why. So first we need to import the fs system file reading. For that we need to import that fs module, file system module, that node.js provides us. Fs, remember these are the tools that node.js provides us. So what I can do is cons, I can make read file obj, or I can say obj will be fine. I can say fs dot read file, or I can say create read file, create read stream, and here I can pass the path name, which is file dot txt. So what it does is that it is giving this object to me, so that I can events, basically this event emitter class that we used, this create read stream is utilizing that behind the scene. and there are events that I can decide. So there's a predefined events that I can define, and what I want to happen when those events are triggered. So there's this event in the create read stream which is data. So I can say file ob read अरे यार read file object dot on, and the event name I have to, these are the event name. As you can see, as soon as I did this string thing, there are so many events: pause, readable, read only, resume, close, data, whatever. Okay, so I am going to utilize this data. Well, this event is going to trigger and it takes the data. So whenever this event data is triggered, this function will be get called. This is what events does, right? So I can just log it, log data. That's it. Now the interesting thing is, here I am not emitting it, meaning I'm not using it, because that is done by create read stream behind the scene. This entire thing is asynchronous. So let me prove to you. So for example, let me just say here other task. So what do you think will happen? So if I'm right, meaning these tasks are asynchronous, so what happens that this will be run first and then this data will be printed second. Because what happens is synchronous tasks runs first and then the asynchronous tasks. Okay, because as soon as it sees, okay, file system create read stream, meaning its file reading task, it will put these tasks into this review library or appropriate task management. Okay, and once the task reading will be done by the OS, or like this review library. Okay, so once the data event is triggered, meaning it will emit them. Emit meaning the data is ready. It will be in chunks, by the way. This function will be run in chunks. Like the entire, we are not reading entire file at once. It's instead what we are doing is one by one, like 64 KB, I guess, bytes. And this does, I will show you in a moment. But so this is what will happen. Once the data events will be triggered, and it will be triggered behind the scene automatically. We don't have to do it. Okay, this function will be run. And as you can see, I'm not using it. That's the beauty of it, that we can just do this. And why do we do that? Remember, this is where a genuinely good software engineering comes, and you will understand why it matters. So let me just first show you this CLS and Node. As you can see, other task is printed first, meaning this is synchronous and this is asynchronous. That's why it's taking time, because it is going to the review library, then the task is being done, and then it is coming to the callback queue, and then it's coming to the event loop, and then event loop is running these tasks. Okay, so there are so many things happening behind the scene. We will understand how it is working, but currently you get the idea, right? And this is buffer. So by default it is like a chunks, like buffer. So in order to convert it to the actual data, we can do to string, and it will print our actual data. This is file data which is coming from this file. This is file data. I will get that idea. Now why does it matter? Well, you see, if this task were too long, like the file was so big, and if it is synchronous, then if I am doing some other task here, it will make me wait, and that is not good. Because remember, a request came, this file reading is happening, so the other requesters are waiting, because it's the synchronous task, and synchronous tasks are run on the main thread, meaning the request that came, remember, main thread, single thread is the same thing, because JavaScript Node.js is a single thread, right? So the entire task will be running on the main thread, and if it is synchronous, meaning this file will be keep waiting for it to complete, then it will go to the next task, and that's not good, because it's keeping wait other tasks, other requests also. But by doing this, what we are doing is we are leveraging the synchronous behavior of Node.js, meaning we are saying, okay, this is file reading task and we don't know how much time it will take. So why don't you just take this and handle for us? And once the data is ready, just do this. This is what events are helping me. Okay, we just register that event, and remember, this is data and we need to like predefine it. It's predefined by the Node.js, so you can't just do anything else. So for example, if I do this, it won't work because it doesn't know the what is this event. So data event will it predefined, which will you get called once the data is ready. So make sure you just use this data. All right. There are some other events also like end, close, and all of these things. They will be run appropriate on the appropriate time. But you get the idea, like what will happen once the data is ready, or the close file, or the end event while the file is end. Now the file reading is end. So if you want to do something on that, you can do that also. But that's the beauty of Node.js. This is how it handles. Okay. And this is features, although we did not directly use that event emitter class. Remember the events, we didn't use that directly, but this file system is using behind the scene that event class that you defined, and dynamically calling that event emitting those events dynamically, so that we can just listen here. So we registered here data event. It is giving us the data, and we whatever we want to do it, we can do it. So we can write into the other file, or we can do here. What we can do here is we can just store into the database. There are so many things that we can do, and it will still not block the main thread because it's asynchronous. So it's happening behind the scene. This task will be done first, and then that's it. The main thread is free. It's handling another request while this task is happening. Once this task is done, we can again. And how does it happen? And who is the responsible for it? We will understand that into the next video, which is related to event loops. Okay. But this is what events about events are equivalent to DOM into the browser, but there's no DOM into the server. So we need this event mechanism which can listen on like we can define on something happened, on error or whatever. So then we can notify the system, okay, something happened, please do something about it. And these events are very powerful because it notifies the system whenever something happened. Like for example, this data is, when the data reading is complete, it will notify the event loop and it will handle the appropriate callbacks. So we will get into that little later, but this is what events, and we've seen how do we create events and how do we use the file system. So next time anything file related comes, you immediately think, okay, and how do you remember these things? Well, you don't. You just read on their official documents what are the events, and once you get to practice to it, you don't have to remember any of these things. You kind of just know, okay, you know what, this is what I have to do. But that's how Node.js is fast, and this is what about events. So that's it, and let's move to the next question. Hello everyone. So let's talk about event loop. This is very powerful thing in JavaScript, in Node.js especially. Well, the idea is our entire uh, Node.js application is fast because of this event loop. Now, how does it work and what does it do? Let's try to understand that. So, when the request comes, and let me just make it very clear first. This is not an official diagram of this event loop. It's just I make it for my like understanding so that I can explain you better. But so don't mind me if it's not the perfect event loop type things. It just I just wrote the component. Okay, these are the like components that are responsible, and not the entire component, but some of them that matters the most. Okay. So with that being said, let's start the video and let's try to move on. Okay, so request comes to the server, meaning on OS level, the request comes and operating systems get the request, and whatever the nginx or whatever we are running with just direct that request to the libview library, which is basically libview library gets the request in layman's term. So what it does is that when the first request comes, the event loop puts that request into the call stack, and it start handling it. What does it mean by handling it? It start reading the code of that entire request handler. So for example, app.get slash user, if that was a route and the request came for that, so it puts that entire route into that uh, entire request handler into that call stack and start running the code. So if there are any JavaScript code that will be run and pretty quickly, by the way, on the main thread. And but if there are any tasks that are asynchronous, so for example, let me show you with an example what do I mean by that. Okay, so this is a basic example that I created. It's the Express server for listening. So this root URL and hello world. So let's try to understand from uh, this that how does event loops come into the picture and how it helps Node.js to become more faster. So what happens is that when I go to the URL or try to hit this URL, it will print hello world. So let me run this server. Node app and server is running. This is getting printed, and if I go to this localhost 3000, so as you can see, here's the hello world. I hope you can see it. Here's the hello world, right? So how did it happen? So first request came to the server, okay, and then its Libero library, what it did was it puts this entire request handler to the our call stack, okay. But because of that, there's nothing asynchronous task is happening. It's just sending the response. So, but instead of that, what we had something like this read file, something like that. So, what it would do is, as soon as it would see that who the event to, Node.js will see that it will put this task into this libu, this libu library or the thread pool. There are so many things going on behind the scene, but you can understand that it will just not, it will remove from the main thread. That is the key point that you should remember. As soon as it sees any asynchronous task, whether it could be reading file asynchronous way or making an HTTP request to the other microservices or OS level thing that we are doing, it will put them into the libu library, or it will remove them to the main thread, and it will put them to the like uh, this background task, offload this task to the this libu. Okay, you handle these thing, and I don't have to deal with them anyway. So while doing that, what it does is that it will keep doing that thing behind the scene, and it will move to the next thing. What does it mean by that? Well, as soon as it sees that okay, these tasks are asynchronous, it will put them into the library library, and it will free the call stack. Meaning, it will do something like this. This is done. Like this request is done. Although it's not technically done because there are so many works is happening behind the scene that read file is doing. We are not yet sent the response to the client, but for now it's done. This event loop said okay, it's empty, and as soon as it is empty, it says this event loop says okay, this is free. So are there other requests? If yes, it puts them into this call stack and it start handling them. While doing that, it also keep checking this callback queue, because remember that task read file we gave to the this libu library. Well, as soon as it is done, this libu library or the appropriate management will push their task to this callback queue. Like okay, the work is done, and now here's the callback that is associated with that. So you can run it after whenever you want. So there are two type of queues. One is micro task queue, which gets handled, meaning what are the promises related tasks that we are doing. So for example, if you are handling any promises, those tasks will go into this micro task, and if it is related to set timeout and reading file or anything like that, it will come into this callback queue. Okay, they will sit there. Okay, whenever the call stack is free, handle them. So this is handling another request, and once the it is free, like it is empty, it will keep this event log is keep checking, and it is checking very fast. So it will put them into the but now what will be get put here is this request and this function. This function will be pushed there, which is callback function. Remember that we have here this callback function will be put here. Let me go here. This will be put here, and it will start executing it. Now the job is done. So it will actually not. It won't get put here because this is actually running already. What will actually put here is that the data with that callback function that the read file is returned to us. So remember that event in the event class we uh, put that register that event on data, and we put that callback. So whatever the data that gave after handling that callback read file, it will put here and we can just run it. So now at this time, the read file is will come, this request will come here again, and it will not, at this time it will return the result, that whatever we are returning it, this will return now. And how does it remember which request, which client to send the response to? Well, this request and response is unique to every request. So because of the closure, so for example, if I show you this request and response, when the request came, it is unique to every request. So this remembers which this response is related to the original request that came. So even though this call stack might be handling other requests at this moment, but at this time, when this callback queue, from the callback queue, whatever the request, the task that we handled and the output came, it's stored into this callback queue. We take this task from this callback queue and we put it into this call stack. But at this time, when we are doing res.send, what we are saying is this response is related to that request that came, original request that came. So it kind of remember it. And why does it remember? Well, thanks to closures. Because of closures, it remembers the original request and response object. Okay, so from that it is able to send the response to the original client that requested this resources or whatever it wanted to do with that. And as soon as it's done, well, it keep popping out from the stack, and it will keep checking and keep pushing them into the stack instead of blocking at them. And that is the reason that event loop makes the node just fast, because it's not, although it is one single threaded, but asynchronous tasks are not handled in the main thread. It is getting handled behind the scene, and while they are getting handled behind the scene, the call stack is ready to handle the next request. And as soon as requests are coming, they are getting put into this. They will wait, by the way, on the server, because in order to process next request, the call stack has to be empty. Okay, they will wait on the server. Call stack is empty. They will put them into the call stack, and they will get start running the code. So in no time from the coming request to the end, there is no instance where our main thread was blocking, like blocked. Okay, this task has to happen, after that I will run the next one. No, there is not in a single line it is happening. And that is the reason it is fast. So it's continuously main thread is working, and that is why we say that it's a non-blocking IO operation, Node.js, because it doesn't block the main thread, or it doesn't wait basically. Okay, and that all thanks to this libview library, and behind the scene that all of this provides and how to handle this asynchronous task. Although we didn't go into in depth like exactly what happened, but we get this clear idea of overall that okay, moral of the story and the crux of this event loop is that it is event loop is like a checker, or responsible for these task callbacks to completely run whenever. So for example, libview notify this callback queue, and once callback queue are ready, okay, there are some tasks that are done, and they are stored in this callback queue. This event loops job is to make sure extract get those tasks from this callback queue and put them into the call stack, and keep checking are there are other requests also, and it is doing continuously. So this is how it does it. And whenever some asynchronous task arrives, what it does, it puts them into the libview. Okay, handle it and move to the next request or move to the next task. That's it. And once those tasks are done, the libview push them into the callback queue, and then event loop check. Okay, I have some notification. Okay, then some tasks are done. Okay, so let me just get those tasks, put them into call stack, and then keep running. So it is continuously running instead of just waiting. There is no point in the time where it was waiting for some task to happen, and that's why it's fast. Node.js is crazy fast, and that's why people are crazy about it. So I hope you get the little bit of idea of it, and I try to explain it in the simpler way. But even if I missed something, you can let me know in the comment section. And yeah, that's it from now. Because I will make it to the next point, next video, because I don't want to make this video too long. I want to keep it little short into the under 1 hour so that you don't get overwhelmed. But let me tell you something. If you can just master these three things that I told you, like what is Node.js, events, and event loop. Trust me, there are so many questions that you already answered. Like what is concurrency and how does Node.js handle? This is the answer. Event loop. This is literally the answer. Event loop. You can just literally explain these things to the interviewer, and he will be happy because this is literally at the core concept. We are done with them. So now, from that point of view, from now the next moving forward, there's nothing like new thing. They will be just using these things. And you will understand every line of the code, like what it is doing and why it is fast and why it's not fast. All right. So if you just come to this point into the video, congratulations, you already mastered most of the Node.js. Because this is it. There's nothing like secret about it. And if you just work with other programming language, then I'm sure you would have liked this much more. And now you can just write software. You can build software without worrying about performance, because now you know that okay, I need to make sure if something is taking time, I need to make it asynchronous. Simple as that. But uh, that's it. And if something takes time, for example, CPU tasks take time. Like for example, if you, but I think we will talk it about in the later videos, and you can let me know what you didn't understand so that I can make a appropriate video about them also. If you want me to explain more in depth with examples, whatever, whatever you want me to do, that you can just let me know into the comment section. And I guess that's the end of this video. I will see you in the next video next Sunday. And yeah,